This video is going to have a look at carboxylic acids. Now, if you've seen the other videos, you'll know that carboxylic acids are one of the 4 homologous series, which is a group of compounds with the same general formula. That general formula is CnH2n plus 1 COOH, and the structure of the 4 that you need to know are here. So if you're not sure on any of these, go back and have a look at the other video, which is in the homologous series section, and that will explain a lot more about this to you. What this video is going to have a look at is the reactivity of carboxylic acids. Now, another name for vinegar is ethanoic acid, which is the first one that you have been looking at. You'll have also perhaps picked up on the video on alcohols that if you take ethanol and leave it in the air for too long with oxygen, it will produce ethanoic acid. So any spirits, any alcohol that you leave out in the air eventually will turn in to ethanoic acid, which is vinegar. And then you will also get water. Now the symbol equation for that is CH3CH2OH or C2H5OH, depending on the way that you want to write it, plus oxygen, O2, gives you ethanoic acid, and H2O, water. Now, the next thing you need to know is the reactivity of each of these. Now, the good thing is, the reactivity is exactly the same as any other acids. So if you're not sure on this, go back to the naming salt section, which I will link to in this area of the learning platform. The first part you need to know is every metal, when it reacts with the carboxylic acid, will produce a salt and hydrogen. So the gas always given off as your byproduct is hydrogen. Now the naming goes exactly the same way. So if I have ethanoic acid and I react it with magnesium, I will get this, which is magnesium ethanoate and hydrogen. If this was butanoic acid, it would be magnesium butanoate and hydrogen. Propanoic acid would give you magnesium propanoate, and so on. If you wanted to write the symbol equation, which would come up in the higher paper, obviously hydrogen is H2, and then magnesium ethanoate is MgCH3COOH2. You then need to go through and balance this. The only thing unbalanced is this part here, because magnesium's got a charge of 2+, that's only got a charge of 1-, therefore you need 2 of those, therefore you need 2 of these over here to balance it. The next thing we'll have a look at is the reactivity of carboxylic acid with a base. So again, this is exactly the same as any acid with a base. You get a salt and water. So propanoic acid and sodium hydroxide, straight away I know I get water as my byproduct. Then the naming is exactly the same as I just showed you. So you'd get sodium, and then you'd take the propanoic acid and that would give you propanoate there. And your symbol equation, again, you take the C2H5COO, you lose the hydrogen because that goes to form water with this here, and then the sodium attaches on. So you replace that hydrogen with the sodium and you get C2H5COO Na plus H2O. The final one we'll look at is a carboxylic acid and a carbonate. Similar again, any carboxylic acid will react like an acid, so when you react it with a carbonate you will always get water and carbon dioxide given off. So if I take butanoic acid and I react it with sodium carbonate, again I will take the name of the metal, which is sodium. I'll take the name of the acid, which is butanoic, so that will form sodium butanoate. I'll then get water and carbon dioxide. So we'll start off with C3H7COOH, add it with sodium carbonate, which is Na2CO3, and then again the similar thing happens. The sodium reacts with the C3H7COO, so I get C3H7COO-Na, I get H2O, and I get CO2. Then it's just a simple case of balancing it, which is that. If you're not sure on any of that, come and see me and I'll go through it with you. The final thing is that litmus paper, blue litmus paper will always turn red, and universal indicator will always turn orangey red. So again, exactly the same as any other acid.